Hi friends, my name is Charan Kumar. I'm explaining from the based on the data structures. So here are the contents. They are the self-introduction, topic, logic, and logic with example and type complexity. Insertion sorting. First means what is the means of the sorting? Sorting is the process of arranging a list of elements in a particular order. I mean sorting. If we are explaining about sorting example, it means just arranging and assigning. What is the meaning of the insertion sort? Insertion sort algorithm arranges a list of elements in a particular order. Insertion sort algorithm, every iteration moves an element from unsorted portion to sorted portion. Here are the steps by steps I have given that, so you can easily understand by the steps how to perform the insertion sorting. The insertion sort algorithm is performed using these following steps. So here are the steps. Step 1, assume that first element in the list is sorted position and all the remaining elements are in unsorted position. And step 2 is take first element from the unsorted portion and insert that element into the second portion in the order specified. Step 3, repeat the above process until all the elements in the unsorted portion. So here is the logic. For I is equals to 1 to size minus 1, temp equals list of I, j equals to I minus 1. While we are using the loop is while temp is less than list of j and j is greater than 0, list of j. So in here you can understand the logic by simply seeing. So for example, I have shared an example is consider the following unsorted list of elements. So here are the unsorted list of elements. We should sort them. That means we should arrange them in ascending or descending order. That is the sorting. Assume that sorted portion of the list empty and all elements in the list are in unsorted of the list as shown in the figure below. So the left side I consider the sorted and right side I consider the unsorted. Move the first element 15 from unsorted portion sorted portion of the list. So first 15 we should sorted and unsorted. So we sorted that 15 and compared them previous one and we sorted them and it comes to first position. To move 20 from unsorted to sorted one, compare 20 with 15 and insert it correct position. So to move element 10 from unsorted to sorted portion, compare 10 with 20 and it is smaller, so swap. Then compare 15 again small. So here we can understand by simply reading this. So we should compare the element with the left side element. If the element is smaller than that, then we should swap them. If it is greater, then we should just simply leave it as and it is the included in a sorted. So here to move element 30 from, again we should compare 30th element with the 20 and here compare 20 with 20, 15, 10 and it is larger than all of this, so that is directly inserted at last position sorted position of the list. So here 30 is compared with the 3 elements which are on the left side, all they are smaller and 30 is the greater, so we should keep as it is and unchange its position and it kept as a sorted list at last end of the sorted list. And again compare and come to the next 50th element from sorted to unsorted to sorted position. Compare 50 with 30, 20, 15 and 10 and it is larger than all this. So 50 is directly inserted last position. So 50 is here the same as 30. 50th element is greater than the before 4 elements in the sorted list. So it is just as unchanged its position and we should keep that 50 in the last position of the sorted list. And next compare 18th. To move element 18 from unsorted to sorted portion, compare 18 with 30, 20 and 15. Since 18 is larger than 15, 20, 30 and 51 position to the right and insert 18 after 15 in the sorted position. That's it. Okay, for next 18 we should compare with the previous 5 elements. So it is 15 is 18 is smaller than the 20, 30 and 15, so kept and greater than the 15, so it is inserted between 15 and 20, 30, 50 elements. So it is inserted after the 50th element. To move element 5 from unsorted sorted position, compare 5 with 50, 30, and since 5 is smaller than all of this, so one position to the right in the list, and insert 5 at the first position in the list. So 5 is always 5 is smaller than the previous element, so it is inserted in the first element 45 unsorted. So to compare 45 with 50 and 30. Since 45 is larger than 30, to move its position in the list and insert 45 after 30 in the list. So since 45 is greater than the 30, but the 45 should be inserted between the 30 and 50. Unsorted portion of the list has become empty. So we stop the process and we finally sort the list. This is the element. So friends, if you observe these elements, these are after sorting. Just you can see that these are arranged in ascending order and descending order. Here is the program example. Hash include less than studio.h. These are header files, and you can use this conio.h if you need, or you can not use this and void main brackets, floor brackets, and int size as a temp. You can use this any alphabets as you know, as you are comfortable with any alphabet. And list of 100 I am taking here is the number for is 100. Maximum limit you can take as you wish. Printf enter the size of the list. How much size you want to take, I mean how many numbers you want to take, that you can enter that many size. Scanf %d ampersand size, and printf enter % integer values and size. For I equals 0, I less than I plus scanf %d ampersand list I. Insertion sort logic. This is the logic from where the insertion sort logic is performed by from this programming. For I is equals to I less than size. These are the conditions. If the loop, it should enter the loop before it satisfy these conditions. Then only it enters the loop. The element should enter the elements. Then the logic will enter and completes its task. These are the other conditions. While temp is less than, if the element is less than, so we can't done that, right? So these are the conditions that based on this only the sorted list will be arranged. List of j plus 1 is equals to j, and j equals to j minus 1. List of j plus 1 equals to temp, and finally printf list after sorting is. So finally we will get this in this what loops. In that loops, what happens, the elements are arranged in a sorted list, that we should again mention that for I equals 0, I less than size, I plus printf %, list of I get ch. If you need, if you starting you use the candidate, you should use here get ch. That's it. Floor bracket. The output is enter the size of the list is 5. Suppose you enter 5 integer values. Has taken that 23, 17, that 4, 42, 30. And list after sorting is 70. So these are arranged in ascending order. This is the sorting. Complexity of the insertion sort algorithm. To sort and unsort a list with n number of elements, we need to make 1 equals to n minus 1 by number of comparisons in worst case. If the list is already sorted and it requires n number of comparables case, 1, 2, best n, and average cases, and to understand this. Thank you, friends.